Welcome to EDU World Space.
So in this question, we have two different particles. One is an alpha particle, or that means a helium atom, and one is a proton. So the proton has a charge of positive E, and it has a mass of m. The alpha particle, which is a helium nucleus, has 4 times the mass and 2 times the charge. They're released from rest, but then they started traveling in opposite directions. We want to find the maximum speed and maximum acceleration for each of these, and we want to know when these maximum values occur. So the easiest thing to find first is the maximum acceleration. Why? Because when these two particles are first released, they will have a force on each other, and it's this repulsion force that makes them start to move. But this force F equals kq1 q2 over r squared. This force decreases the further apart they are from each other. So this force is the largest when they're closest, meaning at the very beginning. So they will also achieve their maximum acceleration from this force because A equals F equal over m, kq1 q2 over mr squared. So because the force is largest when they were just released, their acceleration will be largest when they're just released. So the acceleration of an alpha particle is k times is 2ke squared because it's e times 2e over 4 times m r squared, where m is the mass of a single proton. So this is just 2. Yeah, I think so. Okay, so it's 2 times the mass is 1.67 times 10 to the negative 27 kilogram times r is 0.225 times 10 to the negative 9 meters, and there is a square, and the numerator is 8 times 10 to the 9th Newton meter square per coulomb square times 1.6 times 10 to the negative 19 coulomb again square. Okay, and the acceleration is 1.36 times 10 to the 18 meter per second square. So the acceleration for proton is, again, it's 2ke squared. It's also e times 2e. And now we have a normal mr squared. So where the numerator is the same, times 1 times 10 to the 90. Oh, I forget to add the units. T squared times 2 over 1.67 times 10 to the negative 27 times 0.225 times 10 to the negative 9 squared. Okay, so this ended up being 5.44 times 10 to the 18 meter per second square. So this, you can see, is 4 times larger than the previous one, and that actually satisfies the conservation of momentum. Yeah, so the conservation of momentum we will see is what we need for finding the speed. Like, we can already see it from the acceleration because this momentum has to add up to 0 because it was initially at rest. The speed of the m particle must be 4 times larger than the speed of the 4m particle because m times v of proton plus 4m times v of the alpha particle is 0. So there is that. Another thing we need to let's rearrange it. I will actually change this to minus because I know they're moving in opposite directions, so I don't want to deal with this minus sign. So we have V alpha equals 1/4 of V proton. Okay, so the next thing we need to do is we need to consider the conservation of energy because they are going away because of under the repulsion due to the electric field energy. So the electric potential energy is U equals K Q Q prime over R, or in other words, is 2K E squared over R. This is their initial energy, and all of these are changed into kinetic energy. And the kinetic energy is 1/2 of mv squared, but the m for the proton is just m times v proton squared. And then we have the energy for the alpha particle is 4m times Vp. We see that V alpha is 1/4 of Vp, so V alpha squared is also squared. So this, if we simplify it a little bit, is 1/2 plus 2 times 160. So it's 1/8 is this much. Okay. Okay, so from this we will be able to find V proton because we can rearrange it so that we have V proton equals 5 of 16 K E squared over M R. Okay, and square root. Great. So this is Vp, and we can find it by having 16 times 16 1 9 times 10 to the minus times 1.6 times 10 to the negative 19 squared over 5 times m is 1.67 times 10 to the negative 27 times r is 0.225 times 10 to the negative 9. Okay, let me just stare at this really quick to make sure everything's correct. 4, 6, 8, 5. Okay, I think it looks good to me. So I will keep calculate it, and this turns out to be 4.43 times 10 to the 4th meter per second. And then from here, we know that V alpha is 1/4 of Vp. So it's 1/4 times 4.43 times 10 to the 4th meter per second, which is 1.11 times 10 to the 4th meter per second. Okay, so now we have all the things we want to look for. The maximum speed, the maximum acceleration we've already found here. They occur right immediately. Just follow the released. And the maximum speed is here. And this actually will happen after a very long time, actually infinitely long time. Because why? Because the total energy is the kinetic energy plus potential energy. And if we want them to reach their maximum speed, we want all of the energy to be kinetic energy. So we want the potential energy to be 0, because the potential energy has this form. So the potential energy is only 0 when R is at infinity. So they need to be infinitely far away from each other for them to have the highest speed.